cumulative binomial probability tables. Here are the binomial probability tables from the Edexcel formula book, and we see that we have various n values, the number of trials, n equals 5, n equals 6, n equals 7. So n equals 6, for instance, is all of this table here, and we have various probability of success values p along the top here. So if we knew that we had n equals 6 and the probability of success was 0.15, we'd be looking at these values here. And if we wanted the probability of less than or equal to this, of less than or equal to 3, for instance, then this is the answer. And we don't need to calculate this, it's already calculated for us. We just need to use this in our calculations. So these values here are not the probability that x equals anything. They all represent this, px less than or equal to something. So less than or equal to 1, less than or equal to 2, less than or equal to 3, and so on. So the tables give us a few select values of n, where n is a number of trials. So we've got 5, 6, 7, 8 here, 12, 15, there's 20, there's 25, 30, 40, and 50 will be the last one. The values are rounded, so even these probabilities here, which look like they're 0, they're not actually 0, but to the accuracy of the tables, it would appear as 0. And likewise, these probabilities here are not really equal to 1. They're 0.9999 whatever, so when you round them you get 1. Down here we've got for like this row here, they represent probabilities of px less than or equal to 1. This one here, all of these probabilities are for px less than or equal to 14, and here we've got px less than or equal to 34, and we can see that most of them are rounded to 1 now, and that's why the tables will stop at 38, because they're all showing 1s. It could go all the way up to the number of trials we've got in this particular table, which is 50. It could go to 39, 40, all the way to 50, but there would just be a bunch of 1s in the table, and to cut down on the amount of space they use up in the formula book, they haven't put the rest of the numbers in. But it doesn't stop at 38, so you've got less than or equal to 38, less than or equal to 39, all the way up to less than or equal to 50. So I've taken a snapshot of the tables. So if my n value is 6, n equals 6, then I'm in these tables here. If my p value was 0.15 there, then I'm interested in just this section here now. And if I was looking for px less than or equal to 4, my probability would be this. But these tables only ever give you the probability that x is less than or equal to something. They don't give you equals, they don't give you more than or equal to. There are workarounds for those. These are for cumulative probabilities, and they give the probability that the number of successes is less than or equal to some value. Now question 1 will demonstrate when you come to the probability tables, when there will be a need to look up something here.